Okay, so we're shooting a gun and somebody's going to drop the bullet at the same time and they're going to go like this and they're going to land. And the gun comes out of the bullet comes out of the gun, not the gun comes out of the bullet. The bullet comes out of the gun at 330 meters per second, but that's horizontal. Vertically, it starts at 0. And gravity pulls it straight down. So the only accelerated motion is straight down. The horizontal motion is constant. So this 330 stays constant the whole way. But the vertical velocity is accelerated at negative 9.8 meters per second squared. So it gets bigger as you go down. And the angle between these two components of the resultant vector gets bigger as well. And that's why we fall in a parabolic motion. If we want to find this final velocity overall, this time doesn't count. We're going to have to find the vertical final velocity first. And we're going to use the second formula, and we're going to do the square root thing and blah, blah, blah. And we get about 99 meters per second vertically. You can slow this down and stop and go back and try to solve it yourself if you want. So now we have 99 here, and we have our horizontal velocity, which is? Yeah, but what about it? Is it accelerating? No. Or is it?
Constant.
Constant. Say it with me. Horizontal velocity.
Horizontal velocity.
Is constant.
Is constant.
Good. In physics 11, where there's no air. Okay, so how do we find this? We call this the VR, the resultant vector, or the resultant velocity.
Pythagoras.
We can just do Pythagoras, so you can do the square root of 330 squared plus 99 squared.
And then square root.
And it should be, it's probably about like 360 or something like that.
344.
344? Why is this bigger than either of these two?
It's a right triangle.
It's a right triangle, so the hypotenuse has to be bigger. And you would find that the bullet will speed up as it goes. The horizontal velocity stays the same, but the bullet will actually hit the ground going faster than when it left. So remember that test question that I gave you? That said, if you shoot a bullet out of a gun and you also drop one. By the way, did anybody get the Jazz and the Kaz and the Jesper thing? No? No 6 of Crows here? Wow. Yeah, you know? It's good. It's a good book. It's a good story. Anyway, horizontal stays constant, vertical. And that's why the bullet from the gun will land at the same time, but it will have a different velocity. It will actually be going faster overall. Okay. Velocity also includes what? It's not a scalar, it is a vector, so it has direction. With this, and that's why when Rodman said this should be negative, he's right vertically. But once you get into two-dimensional kinematics, plus and minus start to lose meaning. So for us to get a direction, we need to get this angle. Who's done trigonometry? Okay, what's the saying?
SOHCAHTOA.
SOHCAHTOA, thank you. We have all three, so we can use whichever one. Okay, you have a choice between sine, cosine, and tangent. Who would use sine? Who would use cosine? Poor cosine, nobody ever chooses cosine. Oh, Mateo, thank you. Who would choose tangent? Okay, good. So choose your one and find the angle now. Do it on your calculator. You're gonna need to do this come the end of spring break. So if you don't have a calculator, get a calculator. Put a reminder in your calendar. Send an email to whoever buys you calculators and get yourself a calculator. If you do have one, make sure it works. If you have a graphing calculator, press mode and scroll down 3 rows and you'll see the radian is the default mode. So we don't want radians for this, we want degrees, so you gotta move it over. I'm gonna use tangent. 17 sounds right to me.
Oh yeah, you know so you have the top side and the 99, right? You know where those came from.
So we would say that this velocity is 344 meters per second at an angle of 17 degrees below horizontal. Turn to the person beside you and say the velocity of the bullet at the end. Just before it hits the ground, the impact velocity.
Yeah, close enough.
Farzan, how do you say it? Very good, excellent. 344 meters per second, 17 degrees below horizontal. We would call this the angle of depression.
The horizontal is line or axis?